Welcome to our channel. In this video, I'll explain a very important topic: stack versus heap memory. I'll use simple examples so that anyone can understand. So let's begin. Whenever you run a program, it needs memory to store data. This memory is mainly divided into two parts: the stack and the heap. Think of them as two different drawers where a program stores its data. Each has a different purpose and behaves differently. Let's first talk about the stack. Stack memory is used to store small, short-term data, like function calls, local variables, and parameters. Imagine stacking plates in your kitchen. The last plate you put on is the first one you remove. That's how stack memory works. It's last in, first out, or LIFO. When a function is called, a new block of memory is added to the stack. When the function finishes, that block is removed. It's very fast and efficient, but the size of the stack is limited. Now, let's look at the heap. Heap memory is used for dynamic memory allocation, which means you can request memory at runtime. For example, when you create an object or use the new keyword in many programming languages, that memory is allocated from the heap. Unlike the stack, heap memory can store large amounts of data, and that data can stay in memory even after a function ends, until you manually delete it or the garbage collector removes it. But heap memory is slower to access because it's more flexible and needs extra management. Let's now compare stack and heap side by side. In stack, memory is allocated and deallocated automatically. It has fast access, is limited in size. Data is removed when a function ends. Now let's look at heap. Memory is allocated manually and deallocated garbage collection. Slower access. Can grow as needed. Data stays as long as needed. In simple words, stack is like a notebook, quick and small. Heap is like a hard drive, bigger and longer lasting. Here's a real-world example. Imagine you're working at a desk. You write quick notes on sticky notes, that's your stack memory. You use them for short-term work and throw them away after. But when you write something important that needs to be saved, you store it in a file or folder, that's heap memory. It takes more effort, but it lasts longer. Here's how most programs use both: local variables and functions, stored in the stack; objects, arrays, and large data, stored in the heap. In languages like C++, you manually manage heap memory using new and delete. In languages like Java or C#, the garbage collector handles heap memory cleanup automatically. Knowing the difference helps you write faster and safer code. So, to wrap up, stack is fast, small, and temporary. Heap is slower, larger, and more permanent. Understanding how memory works helps you avoid bugs, memory leaks, and performance issues. If you found this explanation helpful, don't forget to like, share, and subscribe for more videos like this. Thanks for watching.